Okay, here is our final level. And here's what's tricky about this one. We're going to take all the stuff we've already done, and we're going to include what we learned about last week about greatest common factor. Okay, I'm going to embed the practice problems right in here so you can, I'll ask you to pause and give some practice problems a shot right in the middle. Okay, so here is your first example. Okay, so I want to factor this. Now, the thing is, so far, you don't know how to factor anything that doesn't have just an x squared right here. You don't know how to factor something that has 5x squared. Okay, so for this week, this is not something you can factor, and you're going to need to take out a greatest common factor in order to end up with x squared here. So that's kind of a hint for today that it's going to be really easy to find the greatest common factor, because whatever it is, it's got to leave this as just an x squared. Okay, so that's where we're going to kind of start this off. So I'm looking at this, and I might notice that each of these is divisible by 5. But even if I don't notice that, I think to myself, oh, crap, I don't know how to factor this if there's a 5 right here. We'll find out next week, but right now you don't know. So I'm going to factor out a 5, and that's going to leave me with, so let's see, 5 times what gets me 5x squared? 5 times what, if I'm distributing, would get me 45x. 5 times what is 45, right? I'm dividing. 45 divided by 5. That would be 9x. Okay, and 5 times what would get me 70? That would be 14. Okay, and again, in your calculator, 70 divided by 5 would get you that. Okay, so now I've taken out the greatest common factor, and now I have this. Well, and hey, this is just like level 1, right? This is actually 2 positives, so I'm going to bring down my 5. Don't forget it. And now I need 2 numbers that multiply to 14 and add to 9. Okay, I have 2 positives here, so I know both of my numbers are going to be positive. So what 2 numbers multiply to 14 and add to 9? That would be 7 and 2. Okay, and this is called factored completely. Right? I had to factor out the 5 first, and then I noticed this could still be factored, and so this is called factored completely. So the directions on a problem like this would be factor completely, all the way down to where we can't factor out anything else. Okay, now you're going to try. Okay, so try this one. This one's not too different. Okay, so you're going to do this in 2 steps. First, you're going to take out the greatest common factor, which you'll notice will leave you with an x squared right here. Next, you're going to factor this quadratic trinomial. Okay, so go ahead and take a moment. Try that problem. Okay, you should have tried this. Hopefully you pulled out a greatest common factor of 3. And then when you were thinking of 2 numbers that multiplied to 35 and added to 12, hopefully you came up with 7 and 5 there. Okay. All right, here's another problem. Greatest common factor first. Okay. I notice each of these is divisible by 3. I also notice that each of them has at least 1 x. Okay. I also notice, remember, this has to be x squared. We don't know what to do if it's not x squared. So for right now, you know I'm not going to give you a problem that doesn't have an x squared there. So what's going to be on the outside? What number times x squared gets 3x squared? 3x, right? 3 times 1 is 3. X times x squared is x cubed. So I'm pulling out a 3x out of each of these. So this is from last week. So negative 36 divided by 3, right? I can just pull the negative sign down. 36 divided by 3 is 12. And here there's 2 x's, but I'm dividing by 1. So I'm left with just 1 left over. And then 60 divided by 3 is 20. And there's an x here, but I'm dividing by it, so it's gone. Okay, so now what I'm going to do is I'm going to bring this 3x down and then pretend it doesn't exist. Because now I'm factoring this quadratic trinomial, which means I am looking for 2 numbers that multiply to 20 and add to 12. Or excuse me, add to negative 12. So two numbers that multiply. Now they multiply to a positive and they add to a negative. So I know I'm looking at two negative numbers here. Okay, so let's see, two numbers that multiply to 20 and add to negative 12. And I'm really, like, I already know they're negative, so I'm just thinking right now of two numbers that multiply to 20 and add to 12. Let's see, 4 and 5, those don't add to 12. 10 and 2, those add to 12. And here's my answer. Okay. Go ahead and try this one. Here, the greatest common factor was 6x. Remember, that x can be included too as part of the factor, right? Each of these can be divided by 6 and x, okay? And then what you would get if you take out the 6x here is x squared plus 7x minus 30. So then I'm going to bring down that 6x and then pretend it doesn't exist. And what I'm looking for is two numbers that multiply to negative 30 and add to 7. Okay, and remember, this is tricky when this is negative because now what I'm really looking for is two numbers that multiply to 30 and have a difference of 7, right? Because I'm going to need to have one negative and one positive. Okay, so two numbers that multiply to 30 and have a difference of a 7. So let's see, like 5 times 6 is 30, but 6 minus 5 is just 1. So how about 10 times 3 is 30, and 10 minus 3 is 7. So that works. So 10 and 3. Now, which one is positive? Well, let's see. I want it to be a positive 7. So this number is a positive, so I want that larger number to be positive. So this becomes 10 minus 3, which is positive 7. Okay. Here's your third example. We're going to do a full 4 examples here because I really want to show you the possibilities that might come up so you're prepared. Okay, so here is, oops. Here's the next example. Okay, now remember, I need this to be x squared, not 2x, not negative anything. So how am I going to make this x squared? I got to pull out this negative 2. Okay, now these are also divisible by 2, which is, of course means they're divisible by negative 2. But remember, my goal is this guy right here. It's got to be an x squared. Okay, you don't know how to factor it yet if it's not an x squared. Okay, and it's harder. We'll get there, but right now, this has got to be an x squared. Okay, so this is, I'm dividing now by negative 2. So I divided by negative 2. I'm dividing by negative 2. Negative 2 divided by negative 2 is just positive 1. So this is actually just positive x. You can call it positive 1x if that's easier. And then this is 60 divided by negative 2 is negative 30. So now I'm going to bring this down. And now I'm looking for two numbers that multiply to negative 30 and add to 1. So if they multiply to negative, this time I got to think, okay, it's going to be a positive and a negative. And so it's kind of similar to this, except now I need two numbers that multiply to negative 30 and add to 1. So two numbers that multiply to 30 and have a difference of 1. So let's see, 10 times 3 doesn't work. That had a difference of 7. 15 times 2 doesn't work. Here, 6 and 5 will work. And I want the 1 to be positive, so that's positive 6 and negative 5. Okay, try this one. Careful. Careful on this one. Go ahead and pause and try. Okay, hopefully you caught here the greatest common factor is negative 4x. That leaves you with x squared minus 4x plus 3. And when you were searching for two numbers that multiplied to 3 and added to negative 4, hopefully you came up with negative 1 and negative 3. Okay, now, last one, last example. We're used to seeing 3 terms. right? Maybe you look at this and you're like, ooh, I know what's going to happen here. But our first task is this has to be an x squared, right? And we want to pull out the greatest common factor. So here I notice that both of these can be divided by 5. So if I divide by 5, I get x squared minus 45 divided by 5 is 9. And remember, this is the same as, I'm just bringing this 5 down. Remember this? So I need two numbers that multiply to 9 and add to 0. Two numbers that multiply to 9 and add to 0. And that's minus 3 and plus 3. Okay, and here is the last problem in this video, and then it's going to be on you to give it a go. Okay, so go ahead and pause and try that one. Factor completely. Here it is. Here you might have noticed there's an extra x tagged onto each of those, so you got to pull out a 3x. End up with x squared minus 4, which is the same as x squared plus 0x minus 4. So I'm looking for two numbers that multiply to negative 4 and add to 0. X plus 2 and x minus 2. And that's it.